Hello class, I'm working out of your pre-algebra book 5.3 decimal equivalents. To get started, you are asked to convert something like 3/4 to a decimal, then convert by dividing. 3 divided by 4, 3 goes inside the house, 4 on the outside. And then your approach is to remember every whole number has a decimal after it, and we're going to annex zeros after that decimal. Okay, 4 goes into 3 0 times, and we start our division. Bring down, decimal goes straight up from where it's sitting under the dividing sign. 4 into 30 goes 7 times. 7 times 4 is 28. 30 minus 28 is 2. Bring down. And 4 goes into 25 times. 5 times 4 is 20. And this terminates. So 3/4 is equal to 0.75. That is read as 75 hundredths with that TH. Remember your decimal place value names after your decimal. All right, in the next example, we're going to convert 5/12 to a decimal. Let's see what that equals. 5 divided by 12. Okay, 5 divided by 12. Annex a couple zeros there. Let's see what happens with this. 12 goes into 5 0 times. Okay, so we're going to start our division. Our decimal goes straight up. I did the bring down. 12 into 50 goes 4 times. 4 times 12 is 48. 50 minus 48 is 2. Bring down. 12 goes into 20 one time. And this does not terminate. So since we're working with repeating decimals, we're going to keep going to see what we get here. That means we'll annex a couple more zeros to see what happens in the pattern. All right, so that's a bring down. 12 into 80, that will go 6 times. 6 times 12 is 72. And I'm running out of room, so I'm going to take this right here. 80 minus 72 is an 8. And if we bring down another 0, then we see we again have 12 into 80, which goes 6 times. And that's 72. What's happening in the pattern? That 6 is repeating. We're going to use our repeating notation for just the 6. 5/12 is equal to 0.416 repeating. Do we need to put the 0 in front of the decimal? Yes. So attend to that detail. That represents the whole number that is before the decimal, and that gives the purpose of your problem information that it is a 0 and not another whole number. It's sort of like, would you not close the gas cap on your car after getting gas? It's a detail we need to attend to. Okay. We are asked to change 2 11ths to a decimal. We're going to say, okay, well, we have 2 divided by 11. We're going to annex a couple zeros to get started. And we know our decimal goes straight up. You can kind of figure that out as you go or work it. Kind of a fat 2 there from the stylus. Okay, 11 into 2, no, that's a 0. And we bring that down. 2, bring down our 0. 11 into 20, that goes once. And we get 20 minus 11 is 9, bring down. 11 into 90 goes 8 times, it's 8 times 11 is 88. So 2, we're going to annex a couple more zeros because it did not terminate. Okay, 11 into 20. We've seen this before, so that's once. We see a pattern emerging. And we get 20 minus 11 is 9. 11 into 90, that's 8. So we see our repeat happening here in our repeating decimal. We're going to use the math notation for the 1/8, showing that 1/8 repeats after the decimal. Alright, moving on. If we're asked to convert something like 175 thousandths to its reduced rational form using greatest common factor, consider tenths, hundredths, thousandths. This is the place value the decimal ends in. So we're going to say that fraction is 175 over 1,000. It says so. Read the decimal. 175 thousandths. Read the fraction. It matches 175 thousandths. That's how you can check with a really quick check in your mind and mental math that a little bit. If we're asked to use GCF, we can factor tree that down. In this particular one, we can see that it's probably 25. Okay, so you can work the factor tree if it's not obvious. We know how to do that. We've been working with that a lot. And if we use 25, it can at least reduce this fraction quite a bit. Also remember 25 over 25 equals 1, so we're dividing by 1 for the whole fraction. We're not changing the value of the fraction. 175 divided by 25 is 7. 1,000 divided by 25 is 40. And this is a rational form reduced all the way from the original given decimal. Okay, the next idea. You probably haven't seen this idea very much yet with repeating fractions. So it's a little bit of a process. Let's work through converting something like 45 hundredths repeating to rational form. Alright, we're going to set our decimal equal to a variable. It's your first approach. X equals 45 hundredths repeating. Now, we're going to multiply algebraically both sides by probably a 10, 100, or 1,000. That's your box that you'll work out of in base 10 to work a whole number into the other side of the variable. How do you do that? Well, we're going to multiply by 100 here because of the purpose of this problem. So we multiply both sides to keep equivalency, and what happens is that decimal moves, so you're going to have 45.454545. That's what that'll look like. Okay, so you're going to set your repeating fraction, or I'm sorry, your repeating decimal equal to a variable, and then decide what to multiply both sides by so that you can work this problem and create your rational form, your fraction from the decimal. Now the next new step, you're going to take your original expression here and you're going to subtract it from what you decided to multiply both sides by. Watch what happens when you do this. You're going to subtract x equals 0.454545, because this is also equal to And we're moving it down here. Watch what happens. You're getting rid of everything after the decimal. So from what we've done so far, when you're asked to change a repeating decimal to rational form, set that repeating decimal equal to a variable. Decide what you need to multiply both sides by to obtain this right here, a whole number in front of your decimal with the repeat behind your decimal to be able to subtract that expression you decided on when you set it equal to your variable from it. You're getting to whole numbers, but then you're going to work algebraically into a rational form of fraction. So this is a pretty hefty process. There's two major steps here that you have to go out and grab. Okay, 100x minus x, those are like terms. You're subtracting 1 from 100. It's 99x. Okay. Look what happens. That's equal to a whole number, 45 now on the other side. So divide by 99 on both sides, and you're going to have x equals 45 99ths. And we're going to say, oh, 45 divides by 9, and so does 99 divide by 9. So 45 divided by 9 is 5. 99 divided by 9 is 11. 5/11ths is your reduced rational form that is equivalent to the original repeating decimal that you are given. Let's try another one. We're going to take this up a notch. We're going to be asked to convert something like 136 thousandths with the 6 repeating to rational form. Set your repeating decimal equal to x, just like we did before. Alright, we need to multiply both sides by something. It's going to be 1,000. 1, 2, 3 to the right for our decimal to have a nice round whole number. But look what happens here. Just the 363636 repeats after the decimal now. We kind of got rid of the 1 in the pattern. Okay, this is where we take it up a notch. You're going to look this over and see what whole number you can get from your original expression you created just by setting what you were given equal to x. And now what happens is this. You're going to work, let me change the color on that so you can see it. You're going to work with just multiplying both sides by 10 now to get a whole number, because you want to get rid of the repeating numbers in the pattern after the decimal. So you have to decide, what do I need to multiply by on this subtraction to help me get rid of the 363636 just by 10 on both sides. And that keeps equivalence for the x expression that you created. See this? Boom, boom, boom. This is gone. And now, in like terms, we have 1000x minus 10x is 990x. And then 136 minus 1 is 135 on the other side. I'm going to do some algebra here, and we're going to divide both sides by 990. I just repeated what was below to get started here. Okay. 1 plus 3 is 4, plus 5 is 9, and then we have 990. Both of these right away will divide by 9 in our divisibility rules we've worked. You need to track those down, look at your notes, review those, because we are reducing large fractions now, and that's where these divisibility rules that we've practiced before Christmas come into play. So if we do this, we're going to get 135 divided by 9 is 15, and 990 divided by 9 is 110. We can see that that gives us a great start on reducing that big fraction. You can also factor tree it down with the greatest common factor, but this is a mental math that we can do real quick. We're just not done. We have to continue reducing the fraction. The instructions say to reduce to rational form. Rational here would be the fraction. Reduced would be reduce the fraction all the way. So what do we do here? Okay, well, both of these divide by 5 on the top and bottom. So we're going to get 15 divided by 5 is 3. And 110 divided by 5, 5 goes into 11 twice, and that leaves 1, 5 goes into 10 twice, and we get 3/22 for our final answer. Look over this process, practice it in your assignment, see what you can do with what you are given. Remember that you're going through the process of setting a variable equal to your repeating decimal and deciding what do I need to multiply both sides by to create my fraction and get rid of that repeat after the decimal. Whatever it takes in multiplying by 10, 100, or 1000. We did both in this problem. We multiplied by 1000 and 10 in the original expression we created by setting that repeating decimal equal to x to help us, and it does reduce to a fraction in lowest form. I hope this helps, and I'll see you soon.